Hello, everybody. And hi, everyone. This is Aaron Tobin, and I am here with Chris. And Chris and I, we have to tell you, we really apologize for what it turns out to be some rookie technical issues that we have. So we really we are appreciative that you stuck with us. And now let's kind of get started. The purpose of today's session is we want to talk about IBM Observability by Instana, mobile to mainframe observability. And what I'm going to do is focus at first on a context level to be able to tell you more about what is Instana, what is it that it's trying to accomplish, what are the challenges that it addresses. And then Chris is going to get more specific into mainframe and mainframe considerations. So I'm going to move forward from there. Because we are going to tell you a bit about our themes as we move forward, I just need you to know that what we're telling you today is absolutely our plan and what we've delivered and the kinds of things that we are working on now, but getting feedback from you and from others is what helps us tweak our roadmap, update our delivery plans, things like that. So let's kind of get started. This is meant to be at a level of the context. So you'll see, who is it who doesn't have a smartphone, that doesn't have some core application that they use? In this case, it is a money moving application, right? And it's beautiful, it's simple, it is easy to use. It is one button to request money, one button to pay money. And people make use of it because they like your product, they like your application, does for them what they need. But because there's lots of applications that do similar things, what you have to do is ensure that you are providing the right level of functionality, the right performance when a client of yours is using your application. So the user interface is totally simple on the left, but the reality that all of you know about is that in the back end, it is made up of a myriad of servers, of network connections, of applications, storage connections, middleware that is being used, connections to mobile and web apps, servers, as well as in many cases, in most cases for financial transactions, it involves an IBM Z as well. So it is imperative that you know when you're having a performance bottleneck and when are you going to be able to do root cause analysis, restore the service as quickly as you can so that that app that's on the left on the smartphone continues to work as expected and your users are not looking at your competitors to do something instead. So for us, when we looked over the last few years, what we saw is absolutely modern applications and the environments, the infrastructure, the middleware, the services, all of that has become much more complex. And many clients have talked to us about they want to be able to move to AI-powered automation, to be able to speed their getting the applications up and running, keeping them performant, and of course, ensuring that they can figure out what went wrong and restore a service as quickly as possible. And what we've seen, if I go down a little bit, is that there's some key areas because it is multiple clouds, because there are multiple platforms that are used in an application environment, and the tools used to create the components that are running on those platforms, and the stacks of middleware and services and all the connections that go up. What it's come to many people is that there is no single source of truth, that you have to have multiple tools to give you information about each of the different components, and they're not necessarily connected, and they're not necessarily that obvious as to what's going on. We've also seen that costs are rising and that organizations are looking for a way to, how can they put their budgets for IT for next year or for the second half of the year in place and know that they are spending only what they need to, that they're optimized both for the resources that they have as well as for the costs associated for those resources. And those resources are there to be able to support the application environment itself. And then the other part is related to the kinds of staffs that are available, that people are subject matter experts in different areas, and that with fewer people, the need for automation is absolutely clear, because if people are spending their time doing manual steps to either do configurations, to do setup, to do root cause analysis, it's taking them away from key or core tasks that your IT people have been given to help you meet your goals. So over the course of time, this is what we have seen. This is a set of challenges that clients are saying, how do we address this? What's the best way that IBM can help address this? What we did is we at IBM, we looked at how do we address the challenges of all of those key things, of lack of visibility, of being able to get the most optimized resources in place, of being able to help stressed teams automate as much as possible. What we found is that Instana had focused on APM, but had broken out, as it says, broken out of the boundary of APM, which is APM, will tell you, hey, here's what has broken. But what it doesn't do is it doesn't tell you enough context. And so Instana focused on how do we break out of APM and how do we focus on enterprise level observability, where enterprise level observability is focused on automation, context, and intelligent action. And so in the case of automation, what Instana is focused on is an automated full stack application visibility with the ability to detect real-time changes, be able to map the interactions and the dependencies between all of the different pieces that are connected with this application, to be able to do tracing of every request, not sampling, but do tracing of every request that is going through the application, doing profiling such that development teams, DevOps teams can see the working of their code and how well it's performing. And all of this being done with 1 second granularity, no sampling, capture of data on a 1 second granularity. For context, what Instana focused on was really doing that real-time detection and mapping of all of the interdependencies of your application environment. And of course, this is meant to help reduce risk and to decrease the mean time to repair by really ensuring that you're always looking at the most accurate information. So for us, we look at context as we take all of the data that is collected and we put it into context so that you can trace from a user impact down to a line of code that might be causing it. And even in an ephemeral, modern microservices architecture, Instana is built to be able to help you do that. And then the third thing that Instana is focused about is resolving issues faster with an understanding of the contributing factors to it. So with that analysis of every user request from any perspective, you can really quickly resolve bottlenecks, really quickly optimize your performance. So I'm just going to go a little faster on this because we want to be able to get to a demo, it looks like. So some of the things that just on one slide to know about Instana. You'll see on the left the sources of data. It comes from cloud providers, it comes from containers, it comes from Kubernetes environments, and it comes from over 250 different technologies that are monitored and observed, including IBM's platforms, both IBM Z as well as IBM Power. And so if those are the sources, the kind of data that we pull traces, metrics, logs, events, and on goes on from there. What we do is we capture the key data that is needed to be able to provide observability to you. We do the collection. We are big into ensuring that our strategy is to adopt open source so that depending on what interfaces you are using, we're able to capture that information. We do that real-time data processing, so it's every second of collection and capture. The capabilities are the capabilities that you would expect: monitoring, troubleshooting, being able to do analytics, dashboarding to have the visualizations that you need, of course, alerting, and we also have CI/CD insights. So you'll be able to see as you are releasing new applications, or you're making updates to services, or making changes to your application environment, you'll be able to see, here's the impact of introducing your CI/CD pipeline into the performance of your application environment. And of course, root cause analysis and feeding into AI ops as well. The use cases, everything that you can see and imagine, from APM all the way to everything related to full stack observability. And it's focused on being of value and giving very quick time to value for developers, DevOps teams, site reliability engineering, centralized IT operations and application support teams, and even business users have been using it to be able to tie, here's the performance of their business goals, and how does it tie to the performance of the IT that is supporting their business goals. And all of this with 100% collection, 1 second granularity. So if I move from there, what I want to now is, I'm going to pass it over to Chris Walker. But when IBM acquired Instana a little over 1.5 years ago, we focused on how do we take that core capability that's shown in the comprehensive capabilities, and how do we not only continue to invest in all of the technologies and all of the platforms that Instana supports, but how do we add to it IBM technologies like the IBM middleware stack? How do we bring in IBM systems, both IBM Z as well as power systems, and the platforms that are running on top of those hardware systems as well? So with that, I would like to pass it over to Chris. The context of all of this is, we've talked about what is observability, how is it that Instana is there to be able to help you understand the challenges that I mentioned at the beginning. So Chris, if you're ready.
I hope so. Can you hear me okay?
Absolutely.
Okay, so thank you, Aaron. I'm going to move on to the next slide, and I'm going to start focusing on where the mainframe comes into this. So as you heard initially from Aaron there, that the mainframe is underpinning so many of our enterprise's applications and key workloads that are underpinning the business. And so we know from an operational point of view and from at a high level business point of view that successful operations on the mainframe is essential to the success here. But what is very key is that while we want to look at things in an application-oriented view, majority of many solutions today do not have that visibility into the mainframe. They lack that key support that allows you to have that end-to-end view. You get some detailed information about certain parts of the application, but as we'll see, when you hit the mainframe, understanding which particular subsystems it hits or which particular applications are being run is often patchy or indeed missing, so that it makes the whole problem identification, isolation process very difficult to address. So I'm going to start with a couple of key personas who are involved in a lot of cases when we have a problem, or are generally responsible for the successful operation and management of applications and of workloads and of systems within the enterprise. So I'll start with on the right-hand side. This is our traditional subject matter expert on the mainframe. They may have be a mainframe generalist, or they may be someone who is has deep skills in one particular domain. They may be a DBA. They might be a kick systems programmer, for example. They use today mainframe monitoring tools such as IBM's Megamon to get sub-second deep dive information about their particular infrastructure and systems that they manage. And they use those tools very successfully to identify problems and dive deep into addressing a particular issue and solving it. And that doesn't change. The amount of metrics that are available within monitoring tools like Megamon are essential for managing those systems in an infrastructure-oriented way. However, you need to also look at things in terms of an application-oriented view, and that's where someone on the left-hand side, like Mickey, is involved here. Mickey would be a sort of traditional APM user. Someone using Instana, maybe they are an IT operations generalist, or they are responsible for a particular application. They may be an SRE, for example. They want to look at how their application is performing, wherever it is and whatever is touched by it. So it may be something with a mobile front end, which has got an application deployed in the cloud, which then connects through some distributed servers and then ultimately drives transactions on the mainframe. Now, they may not be skilled in understanding how the mainframe works. They may not know what KICS is or DB2, but they are responsible for that application's availability, performance, and also understanding when there is a problem that this can be adjusted. So what we're looking to do here by expanding the view of the end-to-end application onto the mainframe, we're bringing these two users together and showing how they can work together in order to address problems and make sure that applications are running successfully. So I'm going to run through a couple of examples here. Firstly, I'm going to start with what happens if you don't have that view there. You only have a view of distributed side, and we know that the workload hits the mainframe, but we don't have that detailed view of where the application goes on the mainframe. So in this case, perhaps Mickey, the application owner, is looking at a particular problem, and she can see that there is an issue here, and there's a slowdown, and it's coming from the mainframe. But there's a lack of details there. We know what would normally take a second to respond to a transaction is taking 3 seconds, but we don't know what actually is happening inside the mainframe. We don't know which subsystems it's touching and which instances of those subsystems it's touching, which databases should have been updated as a result of this. So you have a couple of ways to try and address this. Firstly, you might call up the person you spoke to last time. And in this case, we'll say, well, let's go to the MQ team because that last time we had an issue, they were the problem. So it might be the same issue there. Alternatively, you might get all of the different mainframe teams on a video call together, or some kind of conference call where everyone is trying to prove their own innocence to the particular problem within their domains, and until you get to the root cause. So if we play this out, Mickey goes to the MQ team, and the MQ team says, it's not our problem today. We've looked at our systems. They all look good. We're responding nicely. There's no particular issues. Have you tried talking to the IMS team? And so we talked to the IMS team, and they noticed that everything is okay on their systems. And in fact, they don't think IMS is part of Mickey's application. So they've been engaged for no reason at all. Ultimately, we do just determine where the issue is that's impacting the application. And in this case, it is within a KICS region. And we engage the KICS subject matter expert, and there's a slowdown there. And they're able to address it and deal with it once that it's been identified. The problem has been that we've gone through a lot of different steps to actually get to the problem. What could have been a problem that could have been solved in minutes rather than hours, or seconds rather than minutes, has taken a considerable amount of time, has engaged lots of different people because we weren't able to get that full end-to-end view of the application. So if I move forward to actually see what the experience should be with a full view, is that now, rather than being unsure of where on the mainframe we need to focus our efforts, by having a view, Mickey's able to see that the slowdown seems to be occurring in kicks. And because it's in kicks, she can go direct to the kick subject matter expert and engage with them, rather than bringing in MQ or IMS or any of the other teams there, and say, we think there's a problem that's affecting this application. And even more than that, because probably the kicks group are looking after dozens, if not, lots and lots of kicks regions to manage, we can give them some details to enable that investigation. We can say, look, you need to look at this particular kicks region, and here's a task ID to go and look at. You can go and address that issue there very quickly. And now they're able to use, for example, a Megamon to go and investigate that and take the appropriate action and fix the issue very, very quickly. So that's a real value, because we may be able to actually address an issue before it becomes noticeable to end users or to affect the actual availability of the application. So I am going to try and do a demo now. Now, I've had a few problems technically this morning, which delayed us, but I'm actually going to try and share the screen here. And I'm going to, fingers crossed, this is going to work. So hopefully, I'm going to ask Aaron just to confirm this. Can you see my screen?
Amazing. Sorry, and I'm saying amazing because we had some technical issues before everybody got on. So okay. It is perfect.
Okay, excellent. Thank you very much. So what I'm going to do is spend a few minutes just walking through what this actually looks like on Instana by having a full end-to-end view. I'm assuming that most of you probably haven't seen Instana or are not overly familiar with it, but you probably have a good idea of what an APM solution interface looks like. So I'm going to spend a little bit of time just showing some of the things within Instana, but also I'm going to get down to what we can show on the mainframe and why that's important as well. So here is a summary view of applications that Instana is tracking today. An application is something that would be something that is being traced from end to end. So we are picking up something and following the flow of the application through to its endpoint. And on here, Instana is tracking the number of services that are engaged in point of that. And you think of a service as a node or one particular technology or instance of a technology that has been identified as part of that application. We also record the number of calls that are being made, the latency or what's the expected throughput time of that application. And then if there's been any erroneous calls that have been identified, what's the percentage of those that have been seen? And with the mainframe side, an erroneous call would be something like an append that's been identified. And Instana will do a quick health assessment based on the baseline of performance that it has seen, and what is how currently measured performance is tracking against the typical amount. So I'm going to pick one particular application that we're going to jump into and look at in a bit more detail, which we call Z Hybrid. And this is an application that we have instrumented that calls from a Docker container running on Linux, calling through to the mainframe. So similar to a typical hybrid application in this. And we can see more details about how this application has been performing in terms of calls and call rate, erroneous call rates and latency, as mentioned before. And then what are the key services that are involved in that. So let's take a look at what Instana has identified that is part of this application. And as this comes up here, you can see that there's a list of all of the different instances, what type of thing it is, whether it's a HTTP server, a database, and what that identified technology is. So we can see here we've got this Nginx server and Tomcat here. This is part of our in our Docker container that's running on a Linux system in the distributed world. But we can also see other things that will be very familiar to mainframe people. So we've got a DB2 in here. We've got Kix regions. We've got MQ. We've got a ZOS Connect as well. So all of these are part of this. And we were also tracking the calls that are going through all of these different services. So, for example, this particular Kix region here has had this many calls, erroneous calls, and what's the health going through there. So we're tracing the performance and getting performance metrics for that application within that particular service. And you can imagine that a Kix region will be servicing many different applications through the many different transactions and programs that are installed in there. But we are looking at it specifically here within the context of the application that we're interested in. So this is a nice table view, but sometimes it helps to look at a more clear view of what that application might be. And I'm just going to load this in here. So here you can see a view that Instana has built up around what this application is. And we read it from left to right. We start the application on this Nginx that called the Tomcat, and then we see all these other nodes here. Now let's assume, for example, that we didn't have any instrumentation on the mainframe, and we just had tracing outside. What we would actually see is probably something like this, where the Tomcat server is calling into via an HTTP request to this host name here. And that's just saying, well, the request went to this endpoint, and here's the number of calls, the number of latency around that. But we have no visibility as to what happened there. Did it call Kix? Did it call MQ? Did it call ZOS Connect? All of those different things involved in that. So what we actually have got by instrumenting further into this is a better breakdown of what actually happened. So we can see from the Tomcat server, we actually went to this ZOS Connect, and the request came through ZOS Connect and went to the first Kix region as part of our flow, which then went to a second Kix region, and then we can also see other things that are part of the transaction flow as well. For example, we've got some MQ in here, but also we ultimately see that the transaction ended up at a DB2. And now, of course, we can now get a really good view of who was involved, who wasn't involved, and as the analysis of performance comes through, where the particular slowdown points might be. So if it's in a particular Kix region, we know we can take a closer look at that, and I'll do that shortly, but also we know who to potentially engage, or if we need to get an expert in to actually look at that particular problem. So how did we build up this tracing of this application? It's not a particularly complex application, but there's enough nodes in there and enough different services to understand or to get the view of how big complex things can be. And the configuration within Instana is very simple. There are, on the distributed side, various sensors and agents. And on the mainframe side, we have a number of data gatherers, or similar to agents, that will be gathering data as it comes through. And you would put these agents on, for example, for collecting Kix information, onto the LPAR, and it will be gathering information as the transactions flow through there. So in order to define an application, we would give it a name, and then we really define just a start point. And in this case, we've decided that the Nginx is the starting point of the application. And we also want to be able to trace all downstream services from that point. And we also want to collect all calls. And you can do more complex filtering and complex instrumentations if there are certain things you want to include or exclude in that part. But in here, we want to follow everything that came from this initial flow. And what that means is that Instana any kind of transaction that's running through here will start to be traced. And as that transaction flows through the system and hits the mainframe, we will start tracing that as we see that coming through, for example, ZOS Connect or Kix. We will see that Instana is tracing that, and we will gather the information that we need to progress with that. So I'm going to just quickly show you what happens if we want to take a closer look at something. So let's pick a Kix region, and we want to look at some analytics of the flows that are coming through this Kix region. So Instana, by default, will be tracing every single transaction that is coming through there. And we can go into and look at the calls that have gone through this Kix region. And as it pulls this back, we can go and look at the performance of a particular trace. And within here, we get to see all of the calls and subcalls within that we have gathered within there. So we can see a timeline of where the delays might be within the service points. And as the overall aggregated time of the application is done, where the delays would be, and where's the most time being spent within kicks. So as we get the calls coming in here, we can see actually where delays potentially might have been and where they may not be, so that we can then isolate a particular problem or reach out around what else we want to do. The other thing that is useful that we gather, and I'm using kicks again here as an example, is the attributes that we gather as the transaction flow comes through. So we can not just say that, oh, there's a slowdown we think in kicks. We can often say, okay, we think it's in this particular kicks region. And here is the actual task number within the kicks region that you should be looking at. So if there's more detail that needs to be done, you can go and look at task history in something like a Megamon and go and see what that particular kicks calls were being done within the system, and that will help with your root cause analysis within there as well. So you're able to get very, very quickly to a particular issue that you want to investigate and isolate this out from other things that are there. Okay, so I'm going to jump back now to the presentation slides as we go further through this. So I want to just talk quickly about what we provide today with Instana. We're just showing a good example with kicks there. So we trace transactions and we expand the transactions that are being traced by Instana on the distributed world into z/OS primarily through kicks and through IMS. And there are very many different ways that you can come into kicks. We can support z/OS Connect, as I just showed there. We can also support HTTP SOAP requests, and we've recently about to add MQ support as well into kicks. And as the request comes in, it can then go from multiple kicks regions. It can go from your TOR to your AOR, or what other setup of kicks regions you've got. You could have a kicks region that writes to MQ, which is then read by another kicks region. And then ultimately you get to something like a call to DB2 or VSAM in order to look at that. Similarly, for IMS, we have similar flows coming in today through z/OS Connect and adding MQ as well. And in the future, we'll be adding support for other flows within to IMS as well as kicks. So with that, I'm going to hand this back to Aaron to talk a little bit about the direction that we're going with Instana at an enterprise level.
All right, good. Thanks. Thanks. And let me get back to that. So what I wanted to be able to do is explain to you what are our integration themes, what are our investment themes. So what we're looking at is in terms of enterprises who have focused on IBM technology, IBM middleware stacks, IBM platforms, we have focused on how do we be the best observability platform for middleware, for the IBM systems, which is IBM Z and IBM Power, and the platforms on those, primarily z/OS, Linux on IBM Z, AIX, IBM I, and Linux on Power. And we've also focused our investments on, for clients who are existing users of IBM monitoring solutions, and so I'll use some acronyms, and for those of you who recognize them, then you know I'm speaking to you. ITM, ITCAM, Smart Cloud, APM version 8, ICAM, the Cloud Pack for multi-cloud management. What we've done is we've created these integration services that allow you to take the metric data that your existing IBM monitoring offerings are capturing, feed that into Instana so it can be used fully in Instana with all of the capabilities, the eventing, the alerting that Chris had shown you as well. And then overall, as you can imagine, we are extremely focused on being able to provide the best observability solution possible. And towards those ends, while we didn't put a slide in here, and I wish I could now, 10 days ago, actually 11 days ago now, the Gartner Magic Quadrant for APM and observability platforms came out. And Instana was put into the Leaders Quadrant. So Gartner has recognized the value, the ability to execute, the vision and the strategy that IBM has put in place with this acquisition of Instana. And we are really pleased with that. And it's a real focus on Instana is IBM's strategic observability platform and monitoring tool going forward. We want all of you to be able to check it out, to play with it, to see how it could be a fit for you as well. And for those of you who are using IBM, existing IBM monitoring tools, with that integration service, we help you in your transition from the existing tools to Instana. And there's many different usage scenarios. There is stop using ITMs, ITCAMs, and fully use Instana. There is some examples of use ITM for pure infrastructure monitoring of traditional virtualized environments. Focus on adopting Instana for new workloads, new applications, for cloud native applications as well, and a number of other different usage scenarios as well. So for us, it is absolutely key that you see that this is what IBM is prioritizing and investing in. And we have a system called AHA Ideas, which is used across IBM. And it is a way for you to be able to submit enhancement requests for the products and to be able to vote on them. So others will see what you put in and they'll vote on them. And we absolutely use those voting patterns as part of how do we prioritize what to invest in next, when should it show up on the roadmap and where. So please make use of that as well. And so speaking of strategic directions, the next slide is one that Chris is going to come back on and talk about as well.
Mm-hmm. Yeah, so what does that mean for Z customers, and where are we going with our future deliverables here? So back in April, at the time of the announce of the new Z16 box, we also issued a statement of direction about some of the near-term deliverables that we will be working towards with Instana. Working up from the bottom, from the three here, I already sort of have mentioned this and showed it a little bit in the demo, is our tracing support through MQ into Kix and IMS, and updates into DB2 that is critical for so many people, as MQ being one of the strategic ways of tracing transactions into the mainframe. The second one that we will be working towards is integration of resource metrics sourced directly from a Megamon. So we know that many of you have a Megamon for your mainframe monitoring. I showed it a little bit earlier, and that will remain fundamental for your infrastructure monitoring and for your subject matter experts to do that. Now, what would then be useful is for some of that information to be fed up into Instana so that you can give additional context and additional value to supplement the tracing information that we gather within Instana, but also have the infrastructure details of the Kix region or the DB2 region in order to show that coming directly from a Megamon, so there is consistent information between everything. So that is something that we're looking to deliver as well. And then the third part is the ability to actually run and deploy the Instana backend service onto Linux on Z. So the choice today is that you can run the Instana server either in SaaS environments, so you feed the data up to the cloud, or you can run it within Linux on x86. So this will be another opportunity or another choice in order to where to deploy if you're very keen on having your Instana infrastructure being managed from your mainframe. Okay, and I think back to Aaron to finish off.
All right. Oh, and I was answering some questions. So I'll tell you what, I'll take back and go to, excuse me, to some other slides. But Chris, can I ask you to kind of look at the questions that are still open?
Okay.
Okay. All right. And so everyone, this one is just a graphic. We see that IBM looks at Instana as that is our observability platform, and it's our strategic platform. Instana, when it was created, in the middle 2010s is, whoops, I just got an alert. It was focused on new cloud native workloads. And so out of the box, out of the gate, Instana focused on and is superb for that. What we have done since the acquisition of Instana is we have focused on what I previously said. How do we help existing IBM clients, both monitoring as well as middleware stack and platform users? How do we help them transition to a modern observability and monitoring platform like Instana? And then how do we also fit into that Instana, well, we have been focused on it as being almost like a standalone tool set in the discussion today. You're going to see that it is a core component of our overall hybrid cloud management solution that is driven by AI ops. And the part that I'm going to mention about that is this. Instana, Turbonomic, IBM Cloud Pak for Watson AI Ops. As we look at IBM's larger hybrid cloud management solution, Instana is there to do the observability, to be able to do that full stack capture of what's going on, give you that enterprise level observability, given the data that helps really make faster decisions as to the performance of your application environment and infrastructure, and determine what to do next to ensure that the services are up to date. As well, Turbonomic is there to be able to, and we feed all the data from Instana into Turbonomic, where Turbonomic is able to do optimization. It does resource management, finding the most optimized resources to use for your application, and it also helps you with getting an optimization for the costs associated for those resources. And all of that feeds into IBM Cloud Pak for Watson AI Ops, which gives analytic insights at a large enterprise level and is really there to be able to help you understand what's the next best step. How do you have autonomous problem determination? And how do you have automated remediation if you want automated remediation? And of course, with learning how to avoid problems in the future. So that's the key parts of Instana, standalone and as part of IBM's larger solution. And one last slide for Chris to be able to give you a kind of summary and call to action.
Okay, thanks, Aaron. And we're still answering some of the questions in the chat, so I'll try and get through all of those as much as possible as well. But hopefully, and thank you for bearing with us with the slightly delayed start, but hopefully you've seen today what we have already done so far with Instana, what the mission of Instana is in order to help you identify application issues, go beyond just monitoring, but actually observability across your hybrid cloud, the ability to identify systems, identify application workloads, and become a single place in order to manage a lot of this information, particularly when there's people who are responsible for lots of different technology being pulled together, but they may not be an expert in all these ways. So that is the way that Instana is going. We've done a lot of work since Instana came into the IBM family about 18 months ago, and we are continuing to invest and grow that as well, with embracing and bringing in the mainframe as part of that as well. So we are delivering a solution here that gives you that full end-to-end insight, we say from mobile to mainframe, and that ultimately benefits the entire IT operations team, regardless of where they actually sit and where their skills are, because as we look at things in an application way, we're able to isolate and support the business in a much stronger fashion. So with that, we'll hang on just to answer a couple of questions within there, if there's anything else. Otherwise, I want to thank you for your time today, whether it's this morning or this afternoon or wherever you are in the world. So I think I'm just going to say that there was one additional. Oh, I think Aaron might have just answered that one about the erroneous calls. So I'd just, on the mainframe side for erroneous calls, it would be something like an append code that we will identify and include that. So if a transaction terminates, we'd be able to capture that, and that would be identified as an erroneous call.
All right. So with that, hey, we kept it right on time. We started late, but we both spoke quickly, but covered all of the material that we wanted to present and demo to you today. So I'll say the same as Chris did. Thank you for joining us. And I hope we get to talk to you again soon.